Welcome back. The topic is mathematical definition or formal definition of Turing machine. A Turing machine is defined by using 7 tuple. So Turing machine M equals to Q sigma and tape alphabet transition comma Q naught comma capital B comma capital F. So totally 7 tuple. Let me explain one by one. Q is the set of states, sigma is the input alphabet. Remember, sigma never includes blank symbols. So meaning that input alphabet not contains any blank symbols B. It is the tape alphabet. Remember, tape alphabet is what are the symbols you are storing in the tape input. Tape is called tape alphabet, so it contains input alphabet as well as blank symbols. So tape alphabet always includes blank symbols. Q0 is the initial state, capital B is the blank symbol which is used to indicate the blank cell in the infinite input tape. You know, blank symbol is always belongs to the tape alphabet, so we can write B is belongs to tape alphabet. Okay. Here also Q0 is belongs to capital Q, capital F is the set of final states, so capital F is subset or equals to Q. Okay, now let me write what is the transition function or mapping function in the Turing machine is. So Q, one of the state in the Turing machine, cross tape alphabet. Now I am reading symbols from the tape alphabet, not the input alphabet. Okay, so Q cross tape alphabet tends to Q. It can move to the next state or remains in the same state, that is depending upon the finite control how it operates. Cross operation on the tape alphabet, either read operation or write operation. Cross, after doing operation, head can move in left direction or right direction. Sometimes you can represent, some authors used to write halting is also one of the option. Head can move in left direction or right direction, or halt the head on the final state, on the accepting state, on the halting state. Turing machine takes 2 arguments, 1 and 1, 2, and produce 3 arguments as the output. I mean, it takes 2 tuples as input and produce 3 tuples as output, 1, 2, either it is head moves in left direction or right direction, or sometimes you can halt the head, I mean reading or writing head. Okay, see what is the state this, I mean after doing operation you can move to the next state or remains on the state depending upon the requirement. Let me write some example transitions. So consider this, for example it is Q0. Now Q0, what is input symbol? A equals to, now I can move to the next state Q1 by overwriting A with X. For example, I want to do, so I am reading A and writing X. Okay, so writing X. So how we can return X comma, after doing operation, I mean I am instructing reading and writing head must move in the right direction. For example, how we return the equation is, this is a transition function, so meaning that after doing operation it can move to this direction. Yes. Now what is present? What is present state is now Q1. What is reading and writing head? Reads the symbol B from the input tape equals to, now I don't want to change the state, remains on the same state. So how I can write Q1 comma, now I want to overwrite B with B only. Okay, so read B, overwrite B with the B only. Yes. Then after that head must move in the left direction. So how I can write Q1 comma B comma L. Okay, now head must move in the left direction, means this is again. Okay, now present state is Q1 transition of q1 comma present input symbol is x, that is equals to, now I want to change to the new state q2, so I can write it is q2. I want to overwrite x with a, so I want to overwrite x with a, yes, a, so I write a comma. Now I want to, after doing operation, I want to move head in the left direction, so I can write L. Okay, so head points to which one? So this is how we can write the transitions in the Turing machine.